All right. Hey, everyone. Welcome to the RSK community call for June this year. I'm Brendan from the Developer Experience team, and welcome everyone. So let's get started. So this call is mainly to discuss RSK IPs. This stands for RSK Improvement Proposals. And the URL for this is on the RSK Smart GitHub organization /RSK IPs. And you will see a repo full of all the files, and each one of them is a particular improvement proposal. And in this call, we will be discussing a bunch of them. And here's the agenda for today, but I would like to introduce Gino, also from the Developer Experience team, to take us through the agenda.
Very much for joining us on this community call. So I'll just go through the agenda for today. So we are going to be, the first speaker is going to be Vlad, and he's going to be talking about RSK IP 290, which is adjust testnet block minimum difficulty. After that, we're going to have Vlad again, also taking RSK IP 297, increase maximum timestamp difference between BTC and RSK blocks in testnet. After that, we are going to have Jose talk about RSK IP 284, new deserialization method for flyover refund address. We're also going to have Jose take RSK IP 293, add method, get active, POPEG, redeem script to bridge contract and perform additional flyover pegging validation. We're going to have Marcos take the next RSK IP, which is 271, peg out batching. And he's also going to handle RSK IP 294, limit the number of inputs to include in a migration transaction. We're going to have question and answer section. So in case you have your questions, you can seize that opportunity. Don't forget to check out, because discussions about this community call was made on our research forum. And in case you want to also contribute to other community calls, like if you have your own ideas of RSK IP that you want to suggest, we can have that discussion on our research forum, research.rsk.dev, community call June, July. We have the QR code there. You can scan that QR code to have access to these URLs. Thank you very much.
All right. Thank you very much, Gino, for that introduction. So we've got quite a lot to get through. But before that, let's start the conversation. So you'll notice at the bottom of many of the slides in this presentation, you'll see there is a link to join our community Slack group, which looks like this one in the top right. This is where we have more fluid discussions, more like a chat group. And there is a research and innovation channel there, which is dedicated to discussing RSK IPs and other research and innovation topics. There is also those who want a more like sort of permanent format than a chat, right? That's a forum. So we've got one discourse instance at research.rsk.dev. This is where it's ideal if you propose your own RSK IPs and discuss existing RSK IPs, no matter what stage they're in. So you can scan the QR codes on screen right now and join those, or we'll post the links in the live streams for you to click on as well. All right. So what are these community calls about? The most important thing is to get the community involved, right? We want to gather feedback, and we also want to provide a way to announce as well as discuss the consensus protocol changes for the RSK network. As mentioned before, the RSK IPs are a formal process for proposing improvements to the RSK protocol, and as the network grows, more and more things will be discovered. There will be more new research, etc. And so the idea is to keep improving all the time, and this is one of the ways these calls are sort of a drumbeat to keep that that information, and distribute that to all of you, our community. These community calls will happen periodically, and will definitely happen every time there is an upcoming network upgrade, which is actually the reason for this particular community call. So the network upgrade for HOP, right, is the next one, and there's this meta RSK IP called RSK IP 291, which basically lists all of the RSK IPs that were included as part of this release. Yes. All right. So here's a bunch of stuff that is included. It was already mentioned by Gino in the agenda, so I'm not going to read those out again. But what I'd like to highlight is that you can go check out the milestone at the link at the bottom, as well as the release candidate, which is a branch on GitHub. What I'd like to highlight is that this release candidate is available for you now for testing, and we would like you to run these nodes and get your feedback on it. However, please do understand that the actual release for 4.0.0 is not going to be exactly the same as the RC, for the same reason that it is in any other software. For example, in this particular release, the activation block number has not been set yet. So, yeah, cool. And moving on, we have the next RSK IP. I believe this one is for you, Vlad. So take it away.
Hello, everyone. I hope you can hear me. My name is Volodymyr. I'm from the core team, and today I'm going to be presenting two RSK IPs. Basically, they are related to the config changes in Testnet network only. First one is RSK IP 290, and it is related to the block minimum difficulty. This RSK IP proposes to adjust minimum block difficulty in Testnet from around 100K to about 500 million. This value is hard-coded in the code, and it is part of the consensus. And the reason being why we need this is sometimes in Testnet network, difficulty skyrockets. For example, when mining pools make their own experiments in Testnet first and then switch to mainnet. Due to that, difficulty first is high, and then when pools move their hashing power to mainnet, this results in no blocks being added to Testnet for quite some time. And this is an issue and not good user experience. Actually, there is a consensus rule in RSK which basically says that if there are no blocks added to the network for 10 minutes, the difficulty drops to its lower value. And what it means is that, and this is why this is a problem, first difficulty skyrockets, then it goes to a minimum value. What happens next is called difficulty adjustment process. And this can take some time, during which many competitive blocks are being generated in the network, and it results in high network workload. And to prevent this kind of situation, as I mentioned, this RSK proposes to increase this difficulty value. As it is only a config change, but it has an impact on the consensus rule, and this is why it needs to be part of a hard fork. Another similar RSK IP, 297, next one. It's about increasing maximum time step difference between BTC and RSK block in Testnet 2. Actually, this is related to RSK matched mining protocol. As some of you may know, each RSK block includes a BTC block header, and there is a consensus rule in RSK which basically says that a difference between RSK and BTC block header should not be more than 5 minutes. And this rule is sort of a security safeguard. This all is good and it all works fine in mainnet, but in Bitcoin testnet, some miners, for some odd reason, generate blocks in the future with timestamps in the future. I guess I should mention here that the Bitcoin network itself does not accept blocks with a timestamp which is more than 2 hours in the future. But even if it is less than 2 hours during that time, no new RSK blocks can be added to the RSK network until BTC timestamp normalizes and fits in that 5 minutes difference limit. And this is basically why this RSK IP proposes to increase this maximum timestamp difference limit in testnet from 5 minutes to 2 hours to allow future BTC blocks being accepted in RSK network. And this RSK IP is also sort of config adjustment in testnet, and it has an impact on the consensus rule, and this is also why it has to be part of some hard fork. Okay, this is all. Thank you.
All right, thank you very much, Vlad. Just wanted to highlight that both of these changes are specific to testnet only, and they do not affect the RSK mainnet. Just wanted to ask if anyone else on stage wanted to add anything to those two RSK IPs, 290 and 297.
Hey, Brendan, I think that something important to remind everyone here is that this is something that the community raised many times. On testnet, as Vlad mentioned, the Bitcoin mining rates are changing all the time, and we have spread bursts all the time. And this has affected the RSK testnet a couple of times, and this is aimed to avoid that in the future. And I think this is something that the community will enjoy a lot. So thanks, Vlad.
Yeah, definitely. Ale Pavager and I have fielded several of those complaints during those incidents.
This is for you guys.
Yeah, it's all of you. So that's going to go away. Yeah.
I have a question for Adrian, I think. Is the date for the hard fork on testnet already set, or is it yet to be?
No. It's not set yet. Maybe we can give after these RSKs are introduced, maybe give some idea of when this will happen. But short answer is no. It's not defined yet. One thing I wanted to add or to clarify, maybe Vlad mentioned that, but just in case, is that this difficulty drop, especially for RSK IP 290, this difficulty drop that happens after there are no blocks for 10 minutes, it's a rule that applies only to testnet, right? It's not a mainnet rule. So basically, because all this instability you can see on testnet coming from the Bitcoin testnet miners. So yes, Jose was saying these two RSK IPs intend to improve the testnet environment for developers. Just wanted to add that.
Yeah, and one another thing that I probably have to mention is that 290 is already activated in testnet. And the other one, 97, is going to be part of HOP, which is future one, right?
All right.
Yeah, and sorry, one more thing, Brendan, is we've seen not that often, but 1 or 2 times big time gaps when there were no blocks in testnet, and that was basically due to this to this rule, this timestamp linking rule that has affected testnet. So we are kind of relaxing that rule a bit in testnet in order to avoid these situations that, as I said, are not often, but they happen 1 or 2 times in the past.
Yeah. All right, amazing. Okay, let's move on to Jose next. Would you like to introduce yourself?
Yeah,
But
definitely.
specifically, I would also like you to say a few things about what Flyover is in general before we get to the RSK IPs. Yeah?
Sure. Thanks,
Awesome.
Brendan. So, okay, my name is Jose. I work in the Federation team or the POPEC team. And I'm going to share with you community 2 RSKPs, both related to the Flyover protocol. We already presented the Flyover protocol in previous community calls, but just to remind you, this is a new protocol that, in a sense, enhances the usability of the pegging protocol. What this enables users is to get the RBTC faster than the regular peggings in order to overcome this delay that the community has raised as an issue many times. In order to do this, what we do is there is a protocol that relies on a liquidity provider, a liquidity bridge contract, and the bridge itself. The liquidity providers are RSK users that are willing to stake their RBTC and advance those RBTC to users in order to receive a fee afterwards after the regular pegging is registered. This protocol makes use of a really clever, I would say, idea of using the same public keys, the same address the same signers that the regular POPEG, but with a quote, a negotiation that is included in the Bitcoin address. In this sense, this means that each of these operations are sent to unique addresses, but all of these addresses are managed by the POPEG. So all the funds that are sent to these different addresses are going to be registered in the bridge and will be used in the RSK as any other fund. But the users will get their RBTC way faster. And on top of that, it will let users to execute smart contracts just by owning Bitcoins. I think that is like the real benefit of this new protocol. So we worked and included Flyover on the past consensus change on Iris, but we detected afterwards that there were some issues. Specifically, this RSKP 284 is meant to fix an issue that we detected on Testnet, which is related to the refund addresses. These refund addresses are used only in the case the locking cap on the bridge is surpassed. What is the locking cap? This was also something that we already added. The locking cap is this limit that we have on the bridge that after surpassed, we are going to start rejecting these transactions until the funds decrease. We are intending to increase this locking cap until we are satisfied with the security levels of the network, and then we are going to remove it at all. But for the time being, we need to ensure that if the locking cap is surpassed, we are going to be able to refund the user or the liquidity provider, depending on the stage of the negotiation, accordingly to a Bitcoin address. Well, what we detected is that the Bitcoin address that we were creating on Testnet were not valid. The way we do this is that we have 21 bytes, and the first byte includes the prefix of Bitcoin. All the addresses on Bitcoin has a prefix depending on the kind of address and the network. Well, for Testnet, there was a special condition that we didn't detect it on Rectest, and it does not affect mainnet, and that we needed to solve. We wanted to solve this and not wait for Hop to be active, so we solved it, and we already activated on Testnet in the same way that Vlad was mentioning as the RSK-IP 290. Taking advantage of this change that we made, we wanted to also enforce that the size of the data was the one that we wanted, which is 21 bytes. So we solved these two issues, and we tried to increase the security of the protocol at the same time, I would say. So this is for 284. We can move to the next one. So this is a different RSKP, but related to the same protocol. We wanted to first solve what I mentioned with 284, because we detected that it was blocking the integrations on Testnet, and we considered that was way more important than have it ready for mainnet. Now that we solved that, we focus on additional improvements to the protocol. This RSKP 293 adds a new method to the bridge that will enable users and liquidity providers to independently validate these unique addresses I was mentioning. In order to do this, what we are giving them is the ability to get the POPEG, the regular POPEG reading script, and then from there compute the unique addresses. This is important in order to ensure the decentralization of the protocol. We don't want users to rely on the liquidity providers, nor liquidity providers making a mistake and looking up for the funds in the wrong address. So we added this method that it will be open. It's in the bridge, can be used by anyone through Web3. And also we added a couple of improvements in the protocol in the sense of taking into account not only the active POPEG, but also the retiring POPEG. This is just for a border scenario where during a migration, there could be flyover pegins being attempted to be registered, sending funds to the retiring POPEG instead of the active POPEG. Again, this is just a safe measure to ensure that no funds will be lost. And finally, but not least, we are also enforcing the verification of the minimum for pegins individually by UTXO. Reminder for the community, UTXO is each of the outputs that a Bitcoin transaction has. We want to ensure that individual UTXOs are respecting the minimums for pegin and not the addition, the summatory of these UTXOs. With these changes, with 284 and 293, we consider that the bridge, the consensus changes, are ready to onboard Flyover, fully ready for mainnet. So we're really happy for that. I think that's it from me. I don't know if the stage has anything to share.
I have a question.
Questions, comments, please.
Go ahead.
Yeah, I have a question for you, Jose. Regarding the previous RSK 284, you mentioned having a Bitcoin refund address. Is there any limitation to the type of address that users can use? Like, can it be a multi-sig?
Yeah, definitely. There are limitations. Thanks for that question, Marcos. We are not accepting native SegWit addresses. We are not accepting base32 addresses. We are only accepting base58 addresses. But in the universe of base58 addresses, we accept any address. This includes the legacy address, the pay-to-public hash, and any kind of a pay-to-script hash, including multi-sigs. Okay, but we are not accepting SegWit native, which is the next version, or Taproot. We are not accepting any of those addresses. So yeah, that's an important verification. And Brendan, you said there are other questions?
Well, I guess a comment from me is that, being able to send a Bitcoin network transaction and then have something happen in a smart contract, it seems a little bit like too good to be true. Maybe let's just, if you can, just explain how that works very briefly.
Yeah, definitely. Thank you. So the way this works is that a wallet that integrates Flyover will let a user indicate a contract and the data that needs to be executed on RSK. And simply by negotiating with the liquidity provider, they will get a Bitcoin address where to send the funds, and that will be it. Okay. Now, this protocol enables the community to build on top of that, right? And the protocol is not going to execute for instance, a conversion from a Bitcoin to RDoc. But we can use the existing protocols the community can build using money on chain, whatever, can build the integrations to execute these smart contracts and convert Bitcoin to RDoc in just one step, in one Bitcoin transaction. And I think that is really a powerful use case.
Yeah, okay, that's interesting. So we aren't providing that directly, but we're providing a protocol enabler for that to happen, which is interesting. Yeah, I can just see how this almost could potentially fit into like the everyday DeFi thing where, I don't want to have to deal with gas fees. So I send Bitcoin into some service provider and boom, I've got a stable coin. And then then from that point on, I can transact entirely in stable coins and maybe use Rift Relay or aggregation or something, and I only have to worry about one currency, right? So that's exciting. Very, very interesting use case.
I don't know, Adrian, if we could share with the community what we are thinking on integrating the Flyover with.
Yeah, go ahead.
Yeah, absolutely.
So I don't know if the community is already aware about the 2AP application that we have deployed some months ago, and that I think it's been really well received by the community. Well, we are starting to work on the integration of the Flyover with the 2AP application. This will let us, or will let the community to start already experiencing this new protocol in the short term. So I think that is actually something really, really nice for us to do.
Awesome. All right. If there's anything else, we'll go to the next section with Marcos. Yeah.
Thank you.
Okay. Awesome. Thanks so much, Jose. Marcos, it's over to you.
Okay. Well, hello everybody. My name is Marcos. I work as a developer of the RSK platform. I'm mainly in the POPREC project and everything related to the bridge and the pay-in and pay-out process. Well, the first RSKP I want to present is the payout batching. The main benefit of this RSKP, or what we are looking for, is to reduce the cost of doing a payout in RSK. Nowadays, when a user wants to get his Bitcoins back, he needs to send RBTCs to the bridge contract, and a Bitcoin transaction is created sending the user his Bitcoin. This has been proven to be a bit expensive sometimes, related to how the bridge selects the UTXOs and the variable fee costs in Bitcoin. So what we propose here is to keep a list of all the payout requests that users make, and every 3 hours, and this is like counted in RSK blocks, it's 360 blocks, but it's approximately 3 hours. Then we create a single transaction that has outputs for each of the users that requested a payout. So this will create like a transaction that it's a bit bigger than the previous case because it will have more outputs, but the cost will be divided among all the users who requested the payout. So making it cheaper for users to do a payout. On the downside, it adds these 3 hours waiting time for users to receive their funds, but they are already waiting for around 30 hours. That it's like the time that we need to confirm the payouts. So we believe that it's a small amount of time that is worth waiting in order to reduce the cost of getting their Bitcoins. So yeah, I don't know. This also comes included with a few new bridge methods that allow users to query when the next payout event will be happening, also how many payouts are in the queue waiting, getting an estimate of the cost of the next payout batch.
I think that is, Marcos, is very important what you say about estimating the costs, because one of the deficiencies is that wallets now cannot, give an accurate estimation of what would be the cost of payout because the UTXO have not been selected. So by this having this method, wallets can present this to the user, so the user can take an informed decision if they want to do a payout through the bridge, or they want to use Flyover, or they prefer to go to a centralized exchange. So I think it's very useful for users to take the best decision.
Yeah, exactly. Thank you, Sergio. Yeah, users can also query how much payout requests are in the queue. So you know that the more requests you have in the queue, the cheaper your payout request will be. Also, a user has the chance to wait until there are more requests in order to do their payout. I think it's important that they have different options. Select the one that's best for them. I don't know if there's any other questions related to this one, or if not, we can move on to the next one.
No, maybe just comment on what you just said, Marcos, about the increase in time for a payout, which it actually will increase on average in 1 hour and a half, of course, depending on when you send the transaction and when the batch is processed. But there are some initiatives, I would say, to decrease that time. One of that is Flyover, that Jose mentioned before, which is now only accepting pay-ins and will accept payouts, but also other improvements coming from the HSM team in order to minimize the amount of blocks required to do a payout. So I think that the impact will be very low in time, while it will be significant in cost. So I think it's a good improvement overall.
Yeah, just to clarify, that time we need to wait in order to process the payouts, it's related to the work that the HSM needs to accumulate in order to sign the payout transactions. So there's a security reason behind that. Like, as you were saying, Adrian, there are plans in the near future to reduce this time. Well, okay. Now the next RSKP, limit the number of inputs included in a migration transaction. Well, this is related to the fact that the use of the platform is increasing, so there are more UTXOs in the reach, and there's more movement in the peg. And there's a hardware limitation in the PowerHSM devices that they can sign a maximum of 253 inputs in a single transaction. So nowadays, when we do a federation change, all the UTXOs registered in the bridge are included in a single transaction with one output to the new federation. So if we found ourselves having more than 253 registered UTXOs, say we have like 300, then a migration transaction will be created with 300 inputs, and the PowerHSM won't be able to sign. So we won't be able to do the migration, and the federation change won't be completed. So this proposal is simply to set a maximum number of inputs to be included in a migration transaction. And in case there are more UTXOs to migrate, well, then a second migration transaction will be created, or a third, a fourth, or as much as we need until all UTXOs are migrated. What we proposed here was to set a relatively low number as the maximum of inputs to include a transaction. We set it at 50, because that will give us the advantage of having more UTXOs in the new federation. So if we have 300 UTXOs in the reach and we migrate them to the new federation at a maximum of 50 per migration transaction, the new federation will have 6 UTXOs available, and that will reduce an issue we have that it's related to the UTXO consolidation, because if we only have one UTXO available, we can process like one payout request at a time. Then we need to wait for the change transaction to be registered and process the next payout request. If we have several UTXO available, it will be faster to process these payout requests. So that's the reasoning behind setting this value of 50 as the maximum.
Something to share here is that what Marcos just mentioned is one of the first steps we are taking on the improvement of the bridge wallet. The payout batching improvement is going to improve the cost of operations. This migration transaction expanding, in a sense, in the UTXOs for the next POPEG improves the timing where the cycles of payouts take place. And we are aiming on the following changes, consensus changes, to improve how the UTXOs are selected, how the UTXOs are consolidated or expanded. We are heavily thinking on how to improve the bridge wallet, because we think as the blockchain starts getting more traction, that this becomes something to consider. So I think this is a really good first step.
Yeah, something important here is that this limitation we added only for the migration, not for the regular payout transactions. The reasoning behind this is that nowadays it's almost impossible that a regular payout transaction would consume more than 250 inputs. To this day, it would imply like taking away all the funds from the bridge in a single payout. But we didn't add this to the regular payouts precisely because, as Jose was saying, there are like different RSK IPs proposed that we expect to implement in the short term that will improve a lot the way the bridge handles the UTXO selection algorithm and the wallet and how fees are paid, and there are a lot of other improvements proposed.
I would like to add. Sorry, Brenda. I would like to add. Maybe it's obvious for the developers and for people that know RSK in depth, but not for the rest of the community, that the whole process of creating the Bitcoin transactions, selecting the UTXOs, managing the funds, it's all commanded by a smart contract that is fully autonomous. So when the developers say we are going to do this, we are going to do that, it's not that they intervene in any way in the process. It's just they have to code, this or improve the smart contracts so that it can perform the right, choose the right UTXOs, the best interest of the users. But the whole process is fully automated. So that's why we are very, very careful, and the developers are very, very careful in introducing changes to the bridge. And I really think that now that I see all the RSKPs, almost all of them are related to the safety of the bridge, and so I'm very, very well impressed that all this work has been doing for the safety of the funds. Thanks to the developers.
Good point, Serge. Good point. Yeah, that's true. We are just upgrading the algorithms. We are not touching anything.
Yeah, I was just going to say, like, perhaps those RSK IPs that Marcos has just mentioned, that's something that we could discuss in a future community call, where, not necessarily related to a release, but, these are RSK IPs in progress in various stages of ideation and, acceptance. Yep. Cool. Any other questions or comments before we move on? Okay, I think that's the last RSK IP, if I'm not mistaken. Before we do a wrap up, yes, it is. Right. So back to Hop. So as I mentioned earlier on, right, the Hop release is imminent, and you can check out the release candidate, and these are the things that have been included. And maybe Adrian, I'm thinking you probably want to say something to round off this present. The set of RSK IPs that we've discussed.
Yeah. So one of the things I wanted to mention today in the call is related to one of the learning outcomes from the RSK Iris hard fork, which was the hard fork just before Hop. And one of these learnings was that it would be better if the scope of the upgrade is smaller, and that we have more frequent upgrades. Iris was quite huge. It has several improvement proposals accepted to be included in it. And so the whole project took months, even 1 year, I believe. But in Hub, we didn't want to repeat this same situation. Having a huge number of changes included in it. So we limited the scope. I believe it's 6 RSK IPs that were presented today. And there were a few things that we had to leave out of Hub. The most relevant consensus rule change that was originally intended to be part of Hub but has not been included is the emergency time lock refresh feature, which is described in RSK IP 264, if I'm not wrong. And I'm mentioning this because there was a public discussion about the introduction of the time lock emergency multisig in Iris in the last or one of the last community calls, where we had John from the sovereign team bringing some of their concerns, which were totally valid. And there was kind of a discussion and which says self-commitment to add an automatic refresh of the expiration time for the UTXO in future hard forks. And this feature is, while we started working on that, it's still under development, but not ready yet. As Sergio mentioned, we try to be very, very careful of not introducing anything that it's not battle tested, and we have reviewed it like 1,000 times. So this particular RSK IP 264 should come in the next network upgrade, most probably to happen by the end of the year, together with other changes that, of course, will be publicly discussed. And yeah, I believe it was important that we mention this. Having said that, it's also important to mention that this time lock emergency multisig is not activated yet. This is because it was coded in a way that it would become active after the first change in the composition of the POPEC members and the signatories, and there was no change to it after Iris hardcore. So from my point of view, at least, it made total sense that we didn't delay HOP and stick to the goal of releasing more often and include RSK IP 264 in the next network upgrade, because today in practice there is no risk associated with the time lock emergency multisig. So that's one of the things that I think it was very important to mention in this call. Going back to Sergio's question about when this is happening, or if there is already established date for this, the short answer is no. The team is in the very last stage of what we call AlphaNet testing. We basically set up a network similar to what Testnet can be and try everything again. So that's almost there. So I believe we will have this release most probably in the next couple of weeks. Once this is released, as you already probably know, activation happens a few weeks after that. In general, a couple of weeks after release, this is activated in Testnet, and 2 weeks after that in mainnets. That's in general what happens. So of course this will be publicly announced. I expect this to be defined and released in the next couple of weeks. So it's like almost happening, but the block activation numbers are not set yet. And I think that's it from my side. I don't know if that answers your question, Serge, the original question.
Yes, and I think, Adrian, this is also a great opportunity to tell the community that we are in the process of preparing, proposing, discussing the RSK IPs for the next network upgrade. I think it will be called HOP2, if there's not a better name, so that if anyone wants to propose something, this is a good time for the discussion and inclusion in the not in Hop 1, but in the following network upgrade by the end of the year, as you mentioned.
Yeah, absolutely. And Brendan mentioned that at the beginning. good place for that, for discussions in between calls, is the research forum, the IOB research forum. Some slide at the beginning, yeah, the link was there. And of course, the public repo for RSK IPs, that's another place that anyone can jump in and make suggestion, comments, or even publish their own RSK IPs. Yeah.
Yeah. Okay. Any other questions or comments from, all the RSK IPs included? Anything we missed, want to discuss? Okay. Looks like we've got it all covered. All right. So let's wrap this up. Today we've heard about 6 different RSK IPs plus 1 meta RSK IP related to the release, and there is a process through which all of the RSK IPs go through. In the very first one of these community calls, we talked about RSK IP 0, which is linked here on the slide. That RSK IP describes what the RSK IP process is, and that means some of the key points is that basically anyone can do it, as Adrian just mentioned earlier on. So you can actually write your own RSK IPs and go through this process, and if that happens, then you'll be presenting in one of these calls potentially. So that's pretty involved, and if you want to participate as well in like maybe a less intense way, less involved way, then you can also participate in existing RSK IPs, right? So there's the GitHub repo for the RSK IPs, and then the discussions generally happen on the forum, research.rsk.dev, which is linked on the screen as well. So multiple ways to participate asynchronously in between these meetings, but then of course there's also these community call meetings where we can discuss it as well. All right. And also let's not forget that we have a chat format as well. So if you prefer chat instead of forums, go to developers.rsk.co/Slack, the link right here at the bottom, and visit the research and innovation channel there, and you will be able, that's the best place to discuss RSK IPs in chat format. All right, so let's continue this conversation. Propose your own RSK IPs, discuss existing ones, and also please let us know what you want to discuss in the next community call, right? So which RSK IPs are of interest to you that we didn't discuss today, or you would like to be discussed the next time, please let us know. And the channels are the same as what we just mentioned. And that's all for today. So thank you very much to everyone, Gino, Sergio, Adrian, Marcos, Vlad, and Jose. Thank you very much to everyone for listening.
Thanks,
Thank
everyone.
you all.
See you next time.
See you in the next
Thank you.
community call. Bye.
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 Ciao.